All right, so let's get into the problems here. So now that we have a little bit of background, let's see if we can't do a few of these. So the first one says, find the arc sine of root 3 over 2. So what I do is I set this equal to something. I'm going to set this equal to theta. Now remember, when you're finding inverses, they flip-flop with the original function. So if the arc sine of root 3 over 2 equals theta, that means the sine of theta is root 3 over 2, right? And remember, our theta, remember how we took the sine and we just cut it off between negative pi halves and pi halves? We had to restrict it. So that's where I'm looking. So I'm looking on my unit circle and I say the sine of what is root 3 over 2, right? So you look at it, you say, okay, I'm looking between negative pi halves and pi halves. And where's the sine equal to root 3 over 2? Okay, there's a sine that's root 3 over 2. So, oh, the sine of pi thirds, or the sine of 60 degrees. Sine of pi thirds is root 3 over 2. Erase this. We know the sine of pi thirds is root 3 over 2. So theta is pi thirds. Hence, therefore, the arc sine of root 3 over 2 is theta. We identified theta to be pi thirds. So next one we got the arc cosine of root 2 over 2. So I say, okay, let me say it equals something. I'm trying to find what theta is. Let me use the fact that the cosine of theta then would be root 2 over 2. And then let me think back to, you remember how we cut off the cosine between 0 and pi? So remember, theta is between pi and 0 when I'm looking for this. So I say the cosine of what is root 2 over 2. So again, I pull up my unit circle. I say the cosine of what, and I'm only looking between 0 and pi now, right? Cosine of what is root 2 over 2? Well, I say there's a cosine that's root 2 over 2. Where's it at? Pi fourths. Cosine of pi fourths is root 2 over 2. Cosine of pi fourths is root 2 over 2. So theta is pi fourths. Therefore, the inverse of the arc cosine of root 2 over 2 is pi fourths. Now let's do it for the arc tangent. The arc tangent of root 3 over 3. So we'll go ahead and set it equal to something. That means the tangent of theta would be root 3 over 3. In other words, the sine over the cosine is root 3 over 3. Now remember, with the tangent, we had to cut that off between negative pi halves and pi halves, right? That's where we had to cut off tangent. So I'm looking between pi halves and negative pi halves for a ratio that will give me root 3 over 3, right? So like, for example, let's say I thought it was like at pi 6, right? Here's pi 6. There's the sine over the cosine. If it was pi 6, I'd have 1/2 over root 3 over 2. So that simplifies to 1 over root 3. And then I'd have to rationalize that. And I get root 3 over 3. And I'm like, oh gosh, I got lucky. It happens to be pi 6. Right? But I'd be looking at that and I'd say, who's got that ratio? You know, is that one over that one? Does it give it to me? I know it's not this one over that one because that's 1. It can't be root 3 over 2 over 1/2 because that's just root 3, right? And it's not negative. Here it would give me a negative. That one over that one's a negative value. That one over that one's negative, and so on, right? That's what I'm looking for on these. And with the arc tangent, again, I'm looking between negative pi halves and pi halves, okay? And if, yeah, let's do that. Let me come back to it. And so, yeah, we're like pi 6. Pi 6 is the one. I know the sine of pi 6 over the cosine of pi 6 is 1/2 over root 3 over 2, which simplifies to root 3 over 3. So theta's got to be pi 6. Therefore, the arc tangent of root 3 over 3 equals theta, which is pi 6. Okay. All right, let's do some with calculator now. So pull up your Desmos. This is the calculator, of course, you can use on the exam. Basic scientific calculator. Let's pull that up. Notice right now I'm in degrees. I want this in radians. There's no degree mark on there, so make sure you put in radians first. And I got to find my arc cosine, or the inverse cosine. There's my arc cosine. I went to function, arc cosine, punch in that 0.7, enter. There it is, 0.7959. Punch that in right here. Of course, you could round that to 2. So 0.795, that, I guess that'd round the 9 up. So we just end up with 0.80, right? All right, let's do that arc sine of negative 1.2 now as well. And actually, before I even do that, the arc sine of negative 1.2, before I punch that in, remember that would be the sine, this is saying the sine of theta would be negative 1.2, right? So the sine of what gives you negative 1.2? Well, this is outside of our range. We don't have the sine of anything giving us something less than negative 1. So this is negative 1.2. So when you punch this in, you're going to see that this doesn't even have a solution on this. The arc sine of negative 1.2. Arc sine, negative 1.2. And your calculator is smart enough to notice that thing is undefined. There is no solution to that, right? The other thing you could think about, with the arc sine, the input has to be between negative 1 and 1 as well for the arc sine, right? Because that's the output of your sine, right? The old domain, the old range of your sine is a new domain, so that value's got to be between negative 1 and 1, or else it's not even going to be doable. So the inverses cancel each other, okay? So the arc cosine of the cosine, they'll just undo each other and just leave you with whatever's in that position, as long as there's some caveats here. As long as, in this case, x is between 0 and pi. Now, that's saying, that's because, that's because that was restricted between 0 and pi. Now, is the cosine typically restricted? No. So you want to put a little star here. Anytime I got a star, if it's not between, then you want to replace with an equivalent theta. Or I'm sorry, in this case, x. Sorry, that's x. Actually, I'm going to leave it as theta. Theta is my x. Okay. Now, that doesn't hold for this one because the arc cosine, and again, the reason is cosine, the only reason cosine is restricted is to find an arc cosine. So this is really not restricted, just the regular old cosine. I can find the cosine of anything. That's why I have a little caveat there. With the arc cosine, I cannot find the arc cosine of anything, right? I can only find the arc cosine of something between -1 and 1. So there's no star for this case. It just holds as is. The next one, this one put a little star on the arc sine of the sine. And if it's not between there, then replace with something that works. And finally, same thing here. If not, again, that's because the tangent normally is just not restricted. You can find the tangent of anything. Okay, that's the reason that you've got some caveats here. So let's do some. Okay, let's do this first one. Tangent of the arctangent, 5.3. So I'm looking right here. Right, tangent of the arctangent. And that says that'll just be 5.3, and I have no restrictions because I could be any real number. So tangent, the arctangent, 5.3 is just 5.3. There's no restrictions there, no problems. Okay. Let's do the next one, sine of the arcsine. So sine of the arcsine, that's this one. Sine of the arcsine is x, as long as x is between -1 and 1. As long as it's between -1 and 1. So I'm looking at that, and I say, is that between -1 and 1? Well, yeah, 98 over 99. 99 over 99 is 1. So, yeah, it's between it. So this is no issue. The sine of the arcsine of 98 over 99, because it's between -1 and 1, is just 98 over 99. No issues. How about the cosine of the arc cosine of root 2? Cosine the arc cosine of root 2. So let's go back up here. Cosine of the arc cosine of root 2. Cosine of the arc cosine of root 2 is root 2 as long as root 2 is less than or equal to 1, greater than or equal to -1. Well, if I punch in square root of 2, it's like 1.4-ish or something like that. So it's bigger than that. There's no caveat. There's no you can replace this, if you will. It just says, well, you can't do that. You can't even find the arc cosine of root 2. So this is not in between there. So you just say no solution. All right, how about the arc cosine of the cosine of pi thirds? Let's come back up here. Arc cosine of the cosine pi thirds. So I'm looking at this one right here, right? Arc cosine of the cosine pi thirds. So then the question is pi thirds less than or equal to pi, greater than or equal to 0? If it is, no issues. And it is, right? Pi thirds is definitely less than pi. So that just is pi thirds. Not an issue at all. They just undo each other. And that's because it's in there. It's in that interval, right? Do the next one. Now, here's where it gets a little bit tricky. Arc sine of the sine of 2 pi thirds. So let's come back up here. Arc sine of the sine 2 pi thirds. So I'm looking at this one. Arc sine of the sine of 2 pi thirds. So it's got to be in here. So then I say, okay, is 2 pi thirds in between there? And hopefully you say, no, it's not. 2 pi thirds is, well, 120 degrees, right? Or maybe you want to write it this way. It's 4 pi 6. That's 3 pi 6. You see how it's bigger than the 3 pi 6? Right? So it's not in there, right? So that's a problem. So I'm looking at my unit circle here. Let me pull up the unit circle for reference. And I say, okay, here's 2 pi thirds. Okay, I needed this to be between negative pi halves and pi halves. And notice that the sine of 2 pi thirds, right? Remember, I was doing the arc sine of the sine of 2 pi thirds. That's what I was doing. And this needed to be between negative pi halves and pi halves. So why does this have a caveat? Well, first of all, there is a sine of 2 pi thirds. Sine of 2 pi thirds does exist. It has no, the sine does not have its own restrictions normally. We only restricted it to find an arc cosine. So the sine of 2 pi thirds is root 3 over 2. So then I say, okay, is there an angle between negative pi halves and pi halves that has the same sine? I say, sure, right there. Who is it? Pi thirds. Pi thirds, sine of pi thirds, is the same as sine of 2 pi thirds. So let's go ahead and write that. The sine of pi thirds is the exact same thing as the sine of 2 pi thirds. So arc sine, sine 2 pi thirds. 2 pi thirds doesn't work. We find that the sine of pi thirds is between negative pi halves and pi halves. So these are the same thing. And now it satisfies this, right? The sine of pi thirds and the sine of 2 pi thirds, right? These are both root 3 over 2, right? And so they'll just undo each other. So it's pi thirds. Therefore, the arc sine of the sine of 2 pi thirds is the same as the arc sine of the sine of pi thirds, which is pi thirds. So our answer is pi thirds, not 2 pi thirds. I know that's very easy to mix that up. Let's do another one that's similar to that, that has a caveat, if you will. All right, how about the arctangent of the tangent of 5 pi 6? Let's come back up here. Arctangent of the tangent of 5 pi 6. So I'm using this one. So it's got to be between negative pi halves and pi halves. Let's go ahead and write that. This is theta, as long as theta is between here and here, as long as it's between negative pi halves and pi halves. Well, 5 pi 6 is not, right? 5 pi 6, you look over here and you're like, oh, 5 pi 6 over here, right? That's not between negative pi halves and pi halves. So the tangent of 5 pi 6 is the sine over the cosine. So 1/2 over negative root 3 over 2. So what I'm doing is, so I'm like, okay, well, it's got to be between negative pi halves and pi halves for the tangent. So do I have another angle that gives me the same ratio of 1/2 over root 3 over 2? I don't want to use that one because that's positive. Remember, this one is a positive over a negative, which will give us an overall negative. So I want to use this one. This will give us the same ratio. Positive over negative, same as a negative over positive. Where is it at? 11 pi 6. Well, it's not 11 pi 6. Remember, I got to think negative. This is negative pi 6. So I got to use negative pi 6 because I got to be between negative pi halves and pi halves is where I'm looking. So I got to use negative pi 6 on this. So the arctangent of the tangent of 5 pi 6 is the same as the arctangent of the tangent of negative pi 6. So we end up with negative pi 6 as our answer. So the arctangent of the tangent of 5 pi 6 is negative pi 6. So again, note those ones that have caveats there. You got to be careful with those ones when they're outside the intervals of interest. Okay. Now let's go ahead and use our skill set. Let's solve a few here. Find the exact values. I'm going to isolate the arc cosine here. So I have the arc cosine, or the inverse of the cosine, is pi over 2. And I'm going to use the fact that the cosine of pi halves then would be x. I'm just solving for x, right? And then I take the cosine of pi halves, right? I look at my unit circle, I take my cosine of pi halves, which is 0. So here, x is 0. So the arc, and I'm just solving for x. Sorry, that's all we're doing. Find the exact value of x. Let's do another one here. Last one. Let's combine all our like terms. So let's subtract 2 arc sine of x, both sides. So we got 5 minus, so we got 3 arc sine of x minus 2 pi equals negative 3 pi. I'm going to add my 2 pi to both sides. So I got 3 inverse of the sine equals negative 3 pi plus 2 pi negative pi. Now I'm going to go ahead and divide by 3. I got to isolate my arc sine. So I got the arc sine of x equals negative pi over 3. And so that means that the sine of, and if you want you can undo it with the sine on both sides. That's another way to think about that. Sine of the arc sine is just x. So I got sine of negative pi thirds. So I look on my unit circle, I rotate negative 60 degrees. And the sine of negative pi thirds is that negative root 3 over 2. Okay. And hopefully that's enough to kind of get you guys started. Thanks so much for watching. See you next time.